Welcome back to my channel, everyone. Sri Tips here. And what we have before us in this clip, this is a whole bunch of karat gold that we recently purchased. And I'm going to try to refine it. If you look over here, I've got a bag, an empty bag. I'm going to put it on the scale, tear the scale to 0. And then now we're going to pull this. This is all 14K gold. And put this on the, look at that, man. Good Lord. I'm going to put this on our scale. We've got 609.5 grams of 14K gold. Over here I have some 10K material. And that's going to be 780. And then here's some 18K stuff. Looks like we got about 850. Take off 10 grams for the bag that I just stuck on there. And we've got 840 grams of karat gold. This is way too much material for me to try to refine all at once. Kind of baffled on what I'm going to do here, but we're going to use this sterling silver that we purchased to try to inquart the gold. But before I do, I'm going to show you something that I found here. If you look at this material, this isn't the stuff that we bought. If you look in here, you're going to see that that thing is marked 14K. And when I cut into it, it's full of plastic. So you gotta watch out for this kind of stuff. I had another piece here. It's marked karat gold on the piece. And then when I cut into it, it's just a very thin coating of gold over some kind of plastic. Same with these earrings. And what I do is when I get this stuff, saved out a couple pieces here. When I get these pieces, now these are actual karat gold, but they're hollow. And when I get them, I take a pair of cutters and I cut into them to open them up to the atmosphere, because if you try to burn this in a melt dish, the air in there will expand and it causes this thing to pop and blow molten metal out of the melt dish. And that's how I found this material here had plastic in it. When I went to do that to relieve the pressure inside the pieces, I found this pieces with plastic in them. This is the largest melt dish that I have, and it's not very big. And so what I think I'm going to have to do here is we're going to have to break these things up into groups and do the inquartation in smaller groups, because I can't fit all this down into this crucible. Just ain't going to fit. That'll work for us. We'll write that down here. It's 298 grams of 14K. Go ahead and write that right here. 298 grams of 14K. I've calculated that I need 377 grams of sterling silver, and that the yield on this amount of gold, 298 grams, should be about 173.7 grams of 24K pure gold. For this first group of 14K gold, we're going to go with 387.5 grams of sterling silver to inquart this group of 14K. For the next batch of 14K, what we'll do, tear the scale to 0, and we're going to put the rest of this right in the melt dish. See if we can pull this off without making a mess. I really do not like working with large amounts of gold like this. It exceeds the capacity of my small hobby operation here. But it makes for a good video, so we're gonna try to do it, try to pull it off. These little bitty pieces in here. All right, I've got everything out of there. So it looks like we've got 313.0 grams. For the 313 grams in this melt dish of 14K, we're going to need 396 grams of sterling silver. And the yield off of this group here should be 182.4. If you look up here, I've got some sterling silver measured out. And called for 396, but I've used 409 here. That should be just fine. That should work for us. Let's get the 10K weighed up here. This is our 10K material in this bag. Pour it right on in. Looks like we've got 167 grams of 10K. Here's our 10K material. I've calculated that I need 106 grams of sterling silver. Look over here. I've got 108.5 grams of sterling silver to go with this amount of 10K gold. This is our 18K material. Put it in this dish. And it looks like we've got 63.5 grams of 18K material. 63.5 grams. And I've calculated I need 120 grams of sterling silver to properly inquart it. And I've got 123 grams up here ready to go. You look here at group number 2, which is the group in our melt dish. We were calling for 396 grams of sterling silver, but I've actually got like 410. So what I'm going to do is, if you remember, a while back, a video or so ago, I had a bunch of gold that spilled onto the melt table. And we're just going to add this right in to this batch right here and include it with this group of 14K. Little review here. This is our first group of 14K and the sterling silver to inquart it. Second group of 14K and the sterling silver to inquart it. The third group, which is our 10K, and the silver to inquart it. And then finally, the 18K material and the silver that we need to inquart it. These pieces do have a little bit of gold on them. So when I start doing the inquartation, what I'll probably do is add this in with this first group right here. And just go ahead and melt this right in with this group so that we can recover the little bit of gold that's going to be on here. If everything goes as planned, looks like we'll be recovering or yielding about 473.3 grams of pure gold. I've got everything set up, ready to inquart out here We're going to do our first batch, 14K that's in that melt dish. And I've got the water board set up down here so we can pour the molten gold on that board and form some nice granules for the inquartation. This is where the silver comes from that I run through my electrolytic silver cell. I use sterling silver to alloy with the karat gold, and then later on in the process, I'll use hot dilute nitric acid boils to pull the silver back out, and I save that liquid that contains the silver, and I recover the silver from that liquid and melt it into shot and run it through my electrolytic silver cell. So this is where the silver comes from. Silver is a byproduct of my gold refining operations. I'm liking what I'm seeing. It all formed individual pieces. Doesn't look like it's clumped together. Getting this water real cold is the key to having it work out right. Very nice. I think that's all loose and in small chunks. I'm going to put our dish on top of this. See if we can pour the imported gold in here without making a mess. I poured it in this pan so that now it'll be a little easier to manipulate. Pour it in this beaker now, carefully. It didn't come out too bad. Rinse this off with some distilled water and get all the tap water off of there, because the next step is to pull the silver that we just added back out of there with nitric acid boils. And if we leave the tap water in there, we're going to form a bunch of silver chloride, which is undesirable. So we're going to rinse it good with distilled water. Try to get all the tap water off there that we can. All right, here we go. That's about a pound of pure gold, alloyed with 3 pounds of silver and base metals. This is our imported gold. About a pound of gold alloyed with 3 pounds of sterling silver. And what we're going to do to start this off is we're going to pull the silver back out of here now. And we could do that now that we've alloyed the additional sterling silver. If we tried to pull the silver out of the high carat 14K and 18K gold and 10K gold, nothing would happen. So we have to alloy additional silver. Now we can pull the silver back out using dilute nitric acid and leave behind just the pure gold. I'm going to add this right in. This will immediately start dissolving out the silver and the base metals from the gold that we just alloyed. It does create a lot of heat, and looks like it's going to boil over, but it won't. If it looks like it's going to boil over, I've got some distilled water here. I can just kind of squirt it in here and knock it back down a little bit. What we'll do is put this, cover it up, and just let this reaction calm down. I'm going to go ahead and pull this up. Put this up on the heat now. Back here, I don't have any heat going to it just yet. I'll set it on the heating pad, wait for that reaction to calm down a little bit. What happens in here is the nitric is going to pull the silver and the base metals out, leave the gold behind, and then once the reaction is complete, we can tell when it's complete, when all the fumes clear up in here. I'll add some sterling silver to this jar, and we'll pour off these nitric boils into this jar that contains sterling silver so that we can consume any residual nitric acid that may still be in this liquid. So I'm going to go ahead and put this on time lapse now, and we're going to begin removing the silver and base metals with hot dilute nitric acid boils. In this sequence, I'm using dilute nitric acid to start slowly pulling the silver and the base metals out away from that inquarted gold. You can see I filled up that silver jar in the back once. I replaced it with a clean jar and added a little bit more sterling silver, and that's designed to consume any excess nitric that I'm pouring off. I've been at this all day and getting a little bit tired out. I think what we'll do is we're going to suspend our activities for today. Now that we've got most of the silver pulled out of the gold, I'm going to transfer the gold into a smaller beaker to make it easier to handle. Let's get this beaker out of the way. It's still warm. It is day 2, the following morning, and what we'll do here is I'm going to pour off some more of this blue liquid. Here you can see what the pure gold is looking like in there. It's looking very good, and the more time we spend in this nitric acid, pulling the copper and the silver out of here, the easier the refining will be later on when we go to aqua regia. Continue the process now in our smaller beaker here. I'm going to add some distilled water. I'm going to pour in an equal amount of nitric acid. Continue doing these nitric acid boils until we've got every bit of the color out of that solution. Put that up on the heat now. Here you can see the acid reacting, creating some more red fumes. The solution is turning blue, a darker blue color, and which indicates that we're still pulling copper. And if we're still pulling copper, it's a pretty safe bet to conclude that we're still pulling silver out of that inquarted gold as well. I think we've gotten all the mileage that we're going to get out of this nitric acid charge. So what we'll do is go ahead and pour this off now into our silver jar over here. This silver jar is going to have our silver in it from the sterling that we used to inquart the gold. And this is where I get my impure silver from to run through my electrolytic silver cell out of this jar. I'll recover this silver from here and use it to run through my electrolytic silver cell. Some more nitric acid. And keep going with this until we get a colorless solution and all the fumes clear up in here when we have it on a vigorous boil. Again, lots of fumes, and the solution turning a dark blue indicates that we're still pulling silver and base metals from the unquarted gold. This is getting lighter, less color, not as deep blue as it used to be, and that lets me know that these nitric boils are nearing completion. This is going to have some excess nitric in it when I pour it off into this jar, so I got to be careful. Pour a little bit on this piece of silver, you'll see. See how that reacts with the silver? So I'm going to have to be careful pouring this in. This is a lot of excess nitric in here, and I could get a boil over. In fact, that's as far as I'm going to go with it right there. I'm going to set it down for a second. Yeah, when we're working with hot acids like this, it's important to go slow and be careful. Let's see what we got here. Rinse this off with some water and put it in this other silver jar. The amount of gold we got here is way more than I'm normally used to working with, so that's why these processes are going to take just a little longer than they normally do, because we have a much greater volume of material that we're working with. Distilled water. I'm going to go in with a little bit more nitric acid now. Like I said, the longer we spend in the nitric acid during this phase of the recovery, the easier that the refining will be later on in the process. Doing these nitric acid boils to pull the silver and the base metals out of there is the longest part of the whole process here. I've worked on it for a couple days now, and I'm still not done, but it does such a fantastic job of cleaning the gold up prior to us going to Aqua Regia to do the refining. It pulls the sterling silver that we added at the beginning of the video, plus any silver and base metals that was already alloyed in with that karat gold. Notice that the solution is a pale blue color now, and our gold looks nice and red. So what we're going to do is pour off this acid. Because it has good active nitric acid in it, we're going to pour this off and save it in this jar here. I'm going to pour some distilled water on the gold now. Now what we'll do is turn the heat down back here and just let this soak in some hot water back here on the heat. While I'm soaking the gold in some hot water, I just wanted to point out here that we've got about 1 kilo of sterling silver that we alloyed with our karat gold. And the amount of karat gold in there is 841.5 grams. And the amount of sterling is 999 grams. So that's a total of almost 1,900 grams of metal that's out there in that beaker. And I think that's why it's taken so long to extract the silver from that gold. I've had this gurgling in distilled water for maybe an hour or so, I guess. But I think what we're going to do is wrap this up, because we've been working all day on this, and I still may have to do one more nitric acid boil to complete the recovery. But for now, the video is already almost 50 minutes long, so we're gonna have to break this up into 2 parts. We're gonna call this a part 1 and pick right up tomorrow morning and start right in on part 2. So this will conclude part 1 of the 15 troy ounce pure gold bar refining. Thank you for watching.